What's up, guys? This is Mr. O'Brien, and we are going to be talking about quantifying matter, Unit 1B. And this is for honor students, so make sure that if you're the honor student, this is your spot to be at. Before we jump into the content, this part one of quantifying matter is going to discuss a little bit about the math required to know for this, to understand the content of quantifying matter. And the math that we're going to be looking at is scientific notation. So let's start off. Tokyo, Japan is really a big city. It's a beautiful city. I've been there. It's an awesome place, culturally speaking. Um, there are about 9,273,000 inhabitants. Um, that's a really big number. Try to imagine memorizing large numbers and remembering the placeholders. That can be challenging. What scientific notation does is tries to simplify this number so that it's more manageable. In this case, the number here that you see as 9,273,000 inhabitants is going to be changed into a number 9.27 times 10 to the 6. Now, how do you do that? How does that work? We'll talk about that in a second. So, again, scientific notation. It's always going to be one whole number, right? Then a decimal, followed by two numbers or one number preceding. And it's going to be also followed by a multiplied times 10 to a certain power. So, you might be wondering, well, why can't it be 2.7 times 10 to the fifth? Well, this can't work, even though these numbers are the same thing. They can't work because the decimal number is not one number behind the whole number. So it's got to be one whole number between 1 and 10, and then raised to a power of an exponent, times 10 to the power of an exponent. Okay. Again, why do we use scientific notation? We use them to simplify extremely small or extremely large numbers. Let me give you some examples that you can try and I can show you. So one of them is going to be the diameter of the sun, which is at 1,392,000 kilometers. And the other one is going to be the density of the sun's atmosphere. Yes, the sun does have an atmosphere. Let's talk about the first one, A. So as you can see, if we can get this decimal number, which you can't tell here, but there's always a decimal number towards the last number here. We're going to move the decimal in this case 1, 2, 3, 4, 5, 6, 6 places to the left. And as we do that, we're going to have a power of 6 times 10 to the power of 6, which is really important. And then we're going to change these numbers as just simplify them as 1.39. Now you might be wondering again, well, why not 1.392? Well, I like to tell my students, because we don't do sig figs in this class, keep it at 3 numbers, right? So whatever your number is, if it's like if it's got 10 numbers or it's got 4 numbers or whatever, the actual number instead of 0, just round it to 3 numbers and it's fine. Consequently, on the other one, when you have a super tiny number, we're going to move the decimal in this case to the right. And as we move to the right in this case, we are going to have a negative exponent, negative 8 times 10 to the negative 8. So we're going to have 2.80 or 2.8, whichever one you want, to the negative 8. Okay, so we're going to have negative exponents moving to the right, and then positive exponents moving to the left. All right. So here's some examples that we covered in class, and I'm not going to give you the answers for these. I want you to try them out, see if you can do them, and if you have any issues, come by and hit me up for a tutorial. As we move on, let's think about how we can do some operations with scientific notation. And the operation I'm going to show you here is addition and subtraction. What's important to know about addition and subtraction is that we need to keep the exponents of the 10 the same in order for the addition or subtraction to take place. Let me go ahead and show you how we do A. Okay. So in the first number, 1.26 times 10 to the 4th, I'm going to change this number to 3. Okay, because I have the 3 right here, 10 to the 3rd. So how do I do that? Well, I got to move the decimal to the right in this case because I got to subtract an exponent here. Remember, right is minus, right? And so as I move the right, I'm going to get 12.6 times 10 to the 3rd. When I have that, I can now bring this guy down, this 2.5 times 10 to the third, bring that guy down, and then add them, okay, together, will get me 15.1 times 10 to the third kilograms. But sometimes I may need to adjust for scientific notation. So I'll move the decimal back here to the left. Remember, moving to the left is a positive number. So we get 1.51 times 10 to the fourth kilograms. Now, there's another way you can do this, right? Maybe you wanted to change this number, right? 2.5 times 10 to the third kilograms. I can change that to 4 by moving the decimal place, watch this, to the left, right? And so now it becomes 0.25 times 10 to the fourth. Now I can get this number, and I can get that number, and without changing anything, I can just add them up, which will get me the same exact number. So you see there's different ways of doing this problem. Here's another one, right? So again, I'm going to try to get this 10 to the minus 1 and match it up to this 10 to the minus 2 here, right? And so I'm going to do that in this way by moving it to the right, because I'm going to subtract it. And then it becomes a negative exponent, right? Minus 1 is minus 2. So 53.6 minus 7.4 will get me 46.2. I move the decimal to the left. It's a positive number. And so now the exponent here is going to be added. So that's why I have a minus 1, right? So minus 2 plus 1 gets me minus 1. And the plus 1 comes from that moving the decimal spot to the left when I adjust. Now, you might be wondering, Mr. Bryan, this is really scientific notation. It's not really a small number. Yeah, you're right. You know, I mean, this minus 1 isn't really a small number. This also can be 0.462. And this is the same number as this one below, right? I'm just showing you because this is a scientific notation notes, but you can get in the habit of understanding some operations. Okay. Here's another example. Once you try about adding and subtracting scientific notation numbers, and if you have any questions, hit me up in tutorial for this. Last piece is the multiplying and dividing. Important note to multiplying and dividing. We just want to multiply and divide the numbers. It makes life way easier on a calculator, just multiplying the numbers, not the exponents. Just multiply the numbers. And the other piece that you need to understand is when we multiply, you add the exponents together. And when you divide, you are going to subtract the exponents together. So let's take a look at problem number 1 right here, problem A. So this problem right here in A, I'm going to multiply 2 and 3. I'm going to put those two together, and it's going to get me 6. Easy. But the exponents for the tens place, I'm going to add those because I'm multiplying, and that'll give me 10 to the third, which will eventually get me 10 to the 5. And in this case, I don't really need to adjust for scientific notation because it's already there. It's 6, right? You can write 6.0 times 10 to the 5th if you like, but it's okay. Dividing is this, slightly different. When I divide these numbers, the 9 times 10 times 10 to the 8th, that's going to be placed on top of the division bar. And then 3 times 10 to the minus 4 is going to be placed below. And then what I'm going to do now is I'm going to get 9 divided by 3 will get me 3. And then the 10 to the 8th minus, because I got to subtract them next, I'm dividing, minus negative 4. So here's the minus. So if you know a little bit about math, when you get negative and a negative, that turns into a positive. So hence, it's going to be 8 plus 4, which becomes 12. So in this case, you don't really need to do any other scientific notation because it's already set up. Or you can put 3.0 times 10 to the 12th. Okay? Now, here's some problems for order of operations regarding multiplying and dividing. So try these out. Hit pause and see if you can figure these out. If you can't, hit me up at tutorial.